What we have here is an electric motor demonstration. I'm going to start out by talking about this electric motor right here. Basically, we're going to have our power source right here, this red wire, this black wire. We're going to have current coming in through this red wire. It's going to come and it's going to contact a set of brushes right here. Now these brushes are going to contact a set of commutator rings. As you can see, there's 4 commutator rings here. And what happens is we're going to have current. We're going to have current flow in this direction through the left side of coil windings, okay? And we're going to have current flow in the opposite direction through the next set of coil windings. And back to this brush right here, through the commutator ring, back to the negative wire. Now what that does, with this coil down here, it's going to generate a field. It's going to generate a field in this direction, in the rightwards direction. And we're going to have current flowing in this direction to the left side coil, and we're going to have current coming toward us in the right side coil. And what that does, because of the Lorentz law, with the field going right and current flowing forward, is we're going to create torque in the upwards direction on the left hand side. And on the right hand side, we're going to create torque in the downward direction. Now what that does with this rotor right here is it allows it to spin. And as it spins, it's going to contact the next set of brushes. And what that's going to do, in turn, it's going to allow current to flow onto the next set of windings. Now as it flows on the next set of windings, we're not going to have any current flow through the other windings over here. And the more windings we have, it's going to allow for smoother motor operation. Now, because this motor right here runs at about 4.5 to 9 volts DC, we have a power source over here. It runs at about 12.5. Now what that allows me to do is create a voltage drop over this circuit, which is, a nice demonstration too. So basically what I've done is I've created this board, and on the upward side of the board we're going to have our positive, and on the bottom side of the board we're going to have our negative. Now I've got some terminals throughout the board. We're going to be able to measure our voltage drop. Now if we come over here, looking at our source voltage, let's hook this guy up real fast. I have a meter right here. This is an ammeter. This guy is going to measure the current throughout the whole system. Now what this does is current's going to flow through this terminal here on the positive side to this switch. Now this switch, I'm going to have a low speed, which I have lit up with an LED, and I have high speed, lit up with another LED. 2 wires coming out of this switch going to allow me to come over here, and I have a resistor pack. This resistor pack's out of a car. It's part of a blower motor circuit, and I have 2 sets of resistors that are wired in series. They're going to allow 2 different voltage drops over the system. One's at about 0.4 ohms, and the other one's about 0.7 ohms. Now, I don't have anything switched on right now, so we're not going to have a motor running, but basically, these terminals right here go over to our motor. And what I'm able to do is I'm able to measure the voltage drop on the right side of this circuit. So I'm going to be able to measure the voltage drop over this motor. Now from this terminal, this positive terminal over here, to this positive terminal over here, while it's running, I'm going to be able to measure the voltage drop over the resistor and the switch. The voltage drop over the switch and the resistor plus the voltage drop over our motor is going to equal our source voltage. Now with this motor running at a higher speed, I'm going to be drawing more current. When this motor is running at a lower speed, I'm going to be drawing less current. We're going to be able to see that. This is a multimeter over here. I'm going to be able to use this to measure our voltage differences at different points of this circuit. And just for demonstration, we can go ahead and hook it up over here, empty circuit. We're not going to see any voltage. Very minimal, very millivolts, nothing. Come over here, hook up our battery, switched on. And you can see there's a source voltage, 12.67 volts. And if we come over here, without any current going through this system, we're not going to see any voltage drop over here. That's because I have this switch off. Now leaving these terminals connected over here, I'm going to switch this guy on low. Now what you're able to see right now is this motor is going to start to spin. I'm having it on the low setting. I'm going through this set of coil resistors right here. You can see we have about a 5.6, 5.8 volt drop over this motor. Now if we come over here, and if we measure our voltage drop across the set of resistors, you can see we're at about 5.5, almost 6 volts there. So that is equal to our source voltage. Now if we look at our ammeter right now, we're looking at about 3.5 amps throughout the whole system, which is about right for running on the low speed. Now if we come over here and switch it on high, you can see our motor begins to spin faster. Look at our voltage drop across the resistor, looking at about 4 volt drop. If we come over here, move my meter over on the negative terminal, you're going to see we're looking at about 6.5, almost 7 volt drop across this motor right now. That's about equal to our source voltage. You see the LEDs switched over to high, switch it back to low. See our current drop back to about 3.3. Voltage drop across the motor, about 5.5. Shut it off, 0 volt drop across the motor. Just what we're looking for. And that's it, folks. Thank you for watching.